This week on Quality Digest Live, we chat with Robin Gomez of GSI Commerce about big data and interpreting the voice of the customer.
Plus, we're engineering the future, but is it really the kind of future we want? We'll find out when we come back.
Welcome back to Quality Digest Live for March 8th, 2013. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, publisher of Quality Digest.
And I'm Quality Digest Editor-in-Chief, Dirk Ducharme. Well, let's get into our first news item. This is Weights and Measures Week.
It is.
I bet you didn't know that.
I did not.
Started by, actually, the first Weights and Measures bill, a little history for you, started by John Adams, signed into law, John Adams, in 1799, which in March 2nd, 1799, which is why the first 7 days of March is always Weights and Measures Week. Now, we use weights and measures a lot. You know, you go to the supermarket and you buy a pound of ground beef or ground horse meat, and you know that if you go over to another market, a pound is still going to be a pound, and that's all because of our Weights and Measures law that makes sure that commerce is always fair for everybody. Well, a lot of people don't realize is that this is kind of an ever-evolving thing. There's constantly new products coming to market that are based on weights and measures and things that we haven't measured before. So for instance, maybe you're planning on buying an electric vehicle. Well, you know, charging stations are showing up around the United States now, but there is no actual official weights and measures calibration and traceability to NIST yet for charging stations. So you go in, you plug in your car, it gives you a certain amount of energy, and it bills you for that, and you're trusting that it is measuring that energy accuracy. Well, NIST is actually currently working on something for this to make sure that there's going to be processes and equipment in place to make sure that the consumer is always buying the amount of energy that they think they're buying and that nobody's being cheated. And new technology is showing up for cabbies and that sort of thing as well. So, but weights and measures are always evolving, and that is basically why we celebrate Weights and Measures Week every year. Go NIST!
Yay!
So there you go. Your geek lesson for the week here.
That was it.
That was it.
Wow, you're
Weights and Measures Week.
You're a lot less of a geek than you normally are.
I told you, man. Minute and a half.
Week. But yeah, no, that was good stuff. Well, you know, NIST always has good stuff. You know who else always has good stuff, Dirk? Is ISO, the International Organization for Standardization, and ISO wants you. Because another news item that we tracked this week comes to us from the International Organization for Standardization, as I said. One of the most widespread of all the ISO standards is ISO 14001, Environmental Management Systems Requirements with Guidance for Use. The popularity of ISO 14001 is not a surprise, as it helps organizations minimize and mitigate any harmful effects to air, water, or land. In today's ever-greening industrial world filled with sustainability-conscious customers, now these are, of course, very important factors. The next edition of ISO 14001 is currently expected to be published in 2015. In order to continuously improve ISO 14001 from its current version, now 9 years old, ISO is asking users to complete a survey on the standard. The object of the survey is to help ISO understand the needs of users and other interested parties in environmental management system standards, such as ISO 14001. Yeah,
you know, a lot of people don't realize, you know, these standards come from ISO, or actually not just ISO, but pretty much any standards organization. And industry is supposed to be involved in this. I mean, not just ISO, but ANSI and all these guys. They solicit from industry, look, we need a standard for this, or we're working on a standard for this. We need input on what you think is important, what should be in a standard.
Or in this case, that we want input on an established standard, like ISO 14001. What has worked for you, what has not worked for you, what needs to be improved in the standard. And that's the way that they continuously improve their standards. Very important. So all individual responses are going to be kept strictly confidential, and the survey data set is going to be made available to those interested parties after all the information is collected. This is a great way to contribute to the evolution of this important standard, and it should take no more than 20 minutes of your time to complete the survey. So to do so, visit online at www.iso.org/ISO/14001 survey 2013. might be easier for you to navigate out to the survey through the story link just below the player page down there. And as always, all the stories that Dirk and I are going to be covering on the show today are available right down there on our player page.
Right. Well, you know, very often on the show we talk about measurement, and in fact we'll be talking about measurement at the end of our show on our Tech Corner with Pinpoint laser systems. But measuring things when we're talking about objects and that sort of thing is pretty straightforward. You have an instrument that simply takes dimensional measurement or light measurement or whatever. But how do you quantitatively measure customer service? Well, that is exactly what our next guest is going to discuss with us. Robin Gomez is Director of Consumer Insights at GSI Commerce, a company that provides phone, email, chat, and social media support to its customers. Hello, Robin. How are you doing today?
Great. How are you guys doing?
Oh, pretty good. Well, real briefly, before we get started, tell us again what exactly GSI Commerce does.
Sure. GSI Commerce is an eBay Inc. company. And definitely what we do is really bringing in the omni-channel experience across multi-channel retailing and interactive marketing solutions for a lot of the world's premier brands. One of the things that we focus on primarily from an operational standpoint is our ability to deliver through a network of fulfillment centers as well as our customer contact centers that we have 4 in the United States.
Okay, now e-commerce obviously is a very competitive industry. How does identifying and addressing customer requirements, you know, in other words, ensuring quality, help GSI Commerce keep its edge?
Yeah, sure. It's a great question. You know, one of the things that we have to do is really make sure that we have some common processes. Supporting over 100 brands in our contact centers really poses its own challenge in trying to make sure that we have some repeatability, that our agents are able to service the customers, and that we're able to still brand the image for our individual clients. So really what we look at is managing on what we can manage, which is really our agents' behaviors. So we look at those agent behaviors, we correlate that against what our consumer feedback is and what the consumer sentiment is, and then we can manage those behaviors in order to make sure that we're getting the right kind of outputs. Really, again, are we getting the consumer experience that we want based upon what we're doing? We really utilize the American Customer Satisfaction Index model in order to be able to understand what those key drivers are, so that then, through our quality assurance programs, we can ensure that we're having our agents perform the right behaviors, which are going to elicit the right responses from our consumers, and ultimately drive the best consumer experience on a repetitive basis.
Well, Robin, we had an article this week that I'm sure you're aware of from Matthew Storm of NIST Systems. And Matthew wrote about a system that you and your team use called interactive analytics from NIST Systems. And that it mines, as we understand it, it mines data from a variety of sources. So maybe you can tell us as a user of this technology, well, what are some of those sources and kind of how does that work?
Yeah, sure. We primarily focus on interaction analytics with NIST on our phone activity. Really what we do is all the call recordings that we have coming in, again, there's just a wealth of information embedded in those recordings and those actual interactions that are happening between the customers and our agents. Really what we're doing with the tool is taking the recordings themselves and analyzing them at a very specific level based upon lexicons, words and phrases that we've defined to say, you know what, this is something that, one, we're either interested in, we want to know more about, it's causing a pain point in our delivery, or something along those lines. So we leverage NIST interaction analytics in order to create categories, also kind of help define what we don't know that's happening in these interactions in order to be able to really, again, hit the plethora of information that we have. We've been able to utilize that in order to really drive efficiencies like average handle time in the call center environment, really look at those process flows from step A to B, where are their pain points for the customers, what don't they understand, what are they communicating to us really real time during those interactions, and being able to take that again and really to drive the consumer experience.
Robin, is this basically, when you're collecting this data, is this basically aggregated data so that you understand kind of what the issues are in general, or do you also collect data specific to a particular customer interaction? And I guess what I'm thinking of is it possible to identify maybe this is a person who calls in a lot, or this is a chronic complainer, or this person has had this issue several times? Is that also part of the system?
Really what we look at is the aggregate, looking at it in aggregate across a product, client, a type of interaction. So not so much at the individual customer level to look at, is John Doe, did he contact us 57 times? But more so, what type of interactions are causing our customers to call us back more than once? What are we not resolving? What are the issues that are more prevalent across our client base, in particular for a specific client?
What are some of the big issues around collecting big data? Obviously, you have a lot of data coming in, both from the system we just discussed, I'm sure from other sources. So you've got a lot of data at your fingertips. How do you deal with all that?
No, absolutely. One of the things about call centers is that there is so much data. Everything that's done, everything that's coming in is measured. That's good and bad. Again, having all of this data, the main thing that we really want to look at is of these millions of contacts that we're getting from phone, email, chat, social interactions, is really narrowing that down and focusing on what are those critical data points. So again, we take a balanced scorecard approach to understand what are those key data elements that we need to make sure that our users, our agents, our supervisors, managers, clients, etc., understand and keep focus on those main pieces of data, structuring them in a meaningful way so that we can take action on it. And a big piece of it is really kind of, I'll use a COPC term, but keeping that data in a QCA format so that we can do something with it, look at trends, avoid anomalies and taking action there, and then applying a Lean Six Sigma process improvement effort where we see that our information isn't going the right way. So again, really paring it down to what's meaningful and what's important out of this mountain of data that we do collect.
We've been talking kind of in an abstract, so I mean, can you give us an example maybe of a type of problem or something that you've been able to detect and then correct based on collecting this kind of data?
Absolutely. So one great example is we had a client that particularly had a very excessive handle time when we were looking at our client base. We wanted to really understand what those drivers were that were impacting that consumer experience, because ultimately, again, we want to be able to help our customers as quickly as possible, and that's what the customer wants as well. By using interaction analytics to really delve into what are those specific process points. So we broke down, really did flow charts of the actual call. What were the steps that were being taken? How long did each one of those steps take? Being able to quickly identify those specific types of interactions using interaction analytics and not have to sit there manually and listen to hundreds of calls, in turn utilizing the system to go through tens of thousands of calls, breaking that down, understanding what those key impacts were and those process steps, modifying them, changing them, and in essence, a great example there is we reduced handle time by 100 seconds within that call type. To really have a huge impact on our overall labor staffing as well as the consumer experience and really our client benefit.
Robin, it's a great example of practical Lean Six Sigma as far as I can see, because you're really going through that demand process, you're crunching your data, and you're improving the process not only for your customers, which of course is always the most important thing, but for yourself as well, for your team, and saving time, eliminating waste, and that's what we're all about. Yep. So for us, I think this is a great case study, great benchmarking opportunity for a lot of folks in a wide spectrum of industries, not just necessarily in your specific industry in e-commerce. So, Robin, we got to go. We got a full show today, but really, thank you so much for joining us and giving us an insight into what GSI Commerce does and how you've gotten to where you are today.
All right, thank you all very much. Have a great day.
Thank you. You too, Robin.
And that was Robin Gomez of GSI Commerce. Yep.
That's right.
Interesting technology, the whole voice analytics and actually monitoring for words and inflection and all that kind of thing.
Check out that article when you get a chance. Again, right below the player pages are all of our story links. It's an interesting technology. Many of us, all of us, really, in some way, shape, or form, of course, deal with calls, incoming calls.
And there's a sidebar on there that talks about the technology in a little bit more detail in terms of the voice aspect of it.
So it's pretty cool stuff. All right, so check that out.
Okay.
All right, well, I have an interesting story myself I wanted to cover this week, Dirk. I didn't actually write it. I wish I could claim that I did write this one, because this is one that's kind of near and dear to my heart. By a writer that I don't think we've had before, Carl Steven.
Right.
Carl Steven is new to us, and his article titled "Engineering the Future" appeared in Tuesday's issue of Quality Digest Daily. Engineering the Future. There it is, right there from Carl Steven. And this article began with a really striking, a very compelling point that I want to show everybody. It's a quick little quote. If we can flash it up on the screen, we can show it now, because he begins with this, and he sets up something that I think he plays out very nicely. Engineers are playing a role in American society that may end American society as we've known it up to now.
I knew that.
I knew that too.
I had a role in that.
But you did, Dirk.
Good thing I got out of engineering and went into the high-paying field of journalism. Otherwise, you guys would be in trouble.
You've changed ripples all over the place.
That's
You've
right.
changed more than I can even desire. But in any event, what Carl is talking about here in this piece is what he says. He sets it up. He says engineers have, through unintended consequences, through their efficiency, through their expertise, have made major changes in our society. And let me explain what I mean by that. Carl uses a couple of data points that I think relate very neatly to this. It's percentage of gross national product dedicated to workers' wages. The percentage of GNP, that is now going to workers' wages is the lowest it has been in nearly 70 years, since 1947, since right after World War II. On the other hand, over the same period of time, 65 years or so, 66 years, the percentage of American gross national product going to corporate profits has increased to the point that it never has been before. So, in other words, you're seeing this split between the GNP going not so much to workers, to wages anymore, and going much more heavily to profits, corporate profits. And there's never been quite the split that we have right now in the last almost 70 years. Now, this is not a screed against excess profits, not by me, not by Carl, not by anybody. I mean, I'm a capitalist. I like money. I think you like money, Dirk, right?
And like I said, that's why I'm in the high-paying field of journalism.
Of course, as am I. So Carl's not saying here in this piece that there shouldn't be profits, and that's not what he's saying, because it could go that way very quickly. But where he's going with this is a more complicated, a slightly more nuanced direction that really gets to the heart of some social issues involved with, again, as I mentioned, the expertise of engineering. So let me explain. Once upon a time in this country, someone with a high school education, or less, he used the example of somebody who maybe had a 10th grade education in 1947, could get a good job, could buy a house, could get married, could support wife and kids, send their kids to college perhaps. You could do that without necessarily even a high school diploma, or only a high school diploma, or maybe some college. Well, that's not the case anymore. Corporate streamlining and an increased efficiency, again, supported and encouraged by better engineering systems, which now are technical as well as theoretical. I mean, engineered systems, physically engineered systems, as well as systems that are kind of service-oriented systems that would streamline the service of business, has really created a situation where companies are so efficient right now, they're so productive right now that they can do more with less, and they can have less employees. But what does that do? What does that do ultimately to American society when you don't have as many good jobs, especially for those that don't have a high degree of education perhaps? What does that do when he talks about the social interaction of good work, of communication is the phrase he uses here. And communication in kind of an older sense, communication meaning that you interact with people and that you exchange things with people, ideas. And good work is a huge part of that. Having good work that you can take pride in and that you can help develop your culture in your local area. And without that, if we've engineered away from having those jobs, if we've made it so efficient for companies to do the same work or more work with 1/10 of the labor force that we had several years ago or several decades ago, where are we at? I mean, it's a similar argument we've heard many times within the realm of robotics, right? We've heard this with robotics a lot. We talked about it just on the show a couple weeks ago, where there's this fear that, well, robotics are going to replace the human interaction on the shop floor, and those people will have to get reassigned, they'll have to get other jobs. And certainly we all want to do that, many of them will, but not all of them will. And many people that don't have a lot of education, maybe don't have more than a high school diploma, or maybe just some college, may not be able to get employed.
So, I mean, yeah, I agree that's true. And I guess I would make the same comment as with robotics or any technological advancements is, yeah, I think that obviously is true, but
what do you do about it?
What do you do about it? I mean, that's just kind of the nature of advancement, I guess. I mean, it sounds cold-hearted, but I mean, it's kind of the way it goes, right?
It is. But and Carl Steven in this article does not assign a solution. He says, I don't know what the solution is.
This is just the case.
This is the case, but this is the reality of it. This is the reality of where we've come from the perspective of being so efficient and engineering so well our processes and our technologies. And, you know, I think the answer is all of us, all of you out there, all of you who are engineers, need to maybe, yes, certainly have a focus on profit, but have a focus on maybe the social nature of some engineering too, where you can maybe help, you know, help create systems where more people can be engaged, can be employed, and be members of society that can get something out of this. Before we go, I know we got to go because we have a busy show, but I want to quote from one of our readers, one of our readers/contributors, Umberto Tonisi, writing from his perch in Italy, and he has an interesting perspective on this as well. He writes, "What happens in the U.S. is happening in the EU, the European Union, too. So I think the phenomenon has to be analyzed in a holistic, more exhaustive, rather than a local way. Thinking holistically or globally is not easy. The planet Earth has no unending resources, and all too many corporations are soullessly doing their best to waste them down," in Umberto's inimitable style. English. "Worker-based GNP is a true sign of a nation's good health." I agree, but it's a little more complicated than Umberto maybe makes it. But certainly there needs to be that profit margin. There needs to be that incentive to have profit. But I think, again, all of us who are in this space, who are dealing with quality, and ultimately quality is about people, we always say that, need to have that perspective too. It's not just about profit. It's not just about engineering our work to be more efficient, to get rid of headcount, and to make more money for the company. It needs to be about more than that. I think we can make it about more than that too.
Right.
That's what that article is
I
about.
agree.
Really good piece by Carl Stevens, so check that one out. Okay, but we're going to move on, and because we have a really cool Tech Corner, and we have a friend who is in the studio with us today, Maury Creighton of Pinpoint Laser Systems, and Dirk and Maury are going to show you right now Pinpoint Laser Systems Laser Microgage 2D in today's Tech Corner. So take it away, guys.
Yeah, well, as we mentioned during our tech check, if you weren't here, I'm here with Maury Creighton from Pinpoint Laser Systems. Maury, welcome to the show. And what are we looking at here?
Well, great, Dirk. It's fun to be here today. This is our Microgage 2D laser alignment system, and Pinpoint Laser Systems for about the last 20 years has been building these systems to help industry and manufacturing companies basically check their manufacturing processes, improve the efficiency of those manufacturing processes, and ultimately to turn out better product through those processes. So
describe the pieces that we see here in front of us.
Sure. This is a fairly typical system, and it really is comprised of three components: a laser transmitter, a digital receiver, and a display unit. And I'll just talk about the laser to begin with. Our laser is basically machined from a solid block of material. It's aluminum. Sides are square and machined flat, and you'll notice there are all sorts of mounting holes around this product, so it can be attached to fixtures or tripods and things like that.
And this is eye-safe laser?
It is. Okay. It's a low-power visible laser. It runs on 4 AA batteries for about 20 hours on a single set of batteries. There is a precision bubble level up here in the top. It's accurate to 10 arc seconds, and in fact the user can take the cover off and adjust it if they decide to do that. And when you turn the laser on, there is a laser beam that comes out the end, and this beam is parallel to the base of the product and also to the sides. So if we set this down on the surface here, this beam can be used out to about 200 feet away. The receiver is similar in design. It's machined from a solid block of material. It's flat and square with, again, mounting holes. And you'll notice in the end here, there is a port, and the laser enters this little port, and it can measure with a detector behind where that laser beam is left and right and up and down. So the laser beam goes into this receiver, and then the receiver is in turn connected to a display unit. In this display unit, you can change the units of the measure from inches, you can save readings and things like that. But it's basically telling you here where that receiver is in a vertical orientation and in a horizontal orientation relative to the laser beam. So if they're both sitting on the same surface, you can see that the vertical reading is reading very near to 0. And if I put just a card underneath this receiver,
this is just a business card.
It elevates it up, and now we can see that that reading has changed.
By about a thousandths, was that it? Okay.
It's showing about 13 thousandths there.
Okay.
And the beauty of the system is that you can make these measurements where this receiver is right up close to the laser, or it can be moved up to about 100 feet away. And depending on customers' applications, we have customers doing all sorts of different things. Well, for example, in the semiconductor industry, they're lining up robotics and transport systems and stages. So they might be working typically in a 1 meter envelope. In the medical world, like MRI scanners and PET scanners and things like that, they're lining up the patient table and the rings that pick up the measurements off of the patient. And so that's a larger envelope. And then we get up to the aircraft and helicopter business, which we do a lot of work in. Our customers buy these systems. They're lining up wing fixtures, landing gear, propeller shafts and ships, all sorts of industries.
How would they have done this in the past, with not using a laser system? What would have been the old way of doing this?
That's a great question. Typically, customers in the past have used piano wire, fishing cord. They've pulled it between machines.
And then they just measure between the wire and their surface to get offsets and so forth?
Exactly.
Okay.
With a ruler, it's effective, but fairly, you get 3 or 4 people making that measurement, you're going to get different answers. And of course,
time-consuming too as well.
Time-consuming and
wire sags.
String sags.
Yeah.
The beauty of using a laser beam is that we're basically just replacing that string with a beam of light and allowing customers to quantitatively measure what that machine is doing so they can then store that information and act on it a little more accurately.
Okay, I notice you've got a few other little options that go with this.
We do. This particular attachment right here is called our 90 line, and what it is it's got an optical pentaprism in here, and when I place this into the laser path, there's a beam that comes up that is vertical, and this beam can be actually adjusted. As I turn this piece, the beam can be deflected around through a plane that's square to the original laser line. So this becomes very handy when you take this receiver and want to check the squareness of machinery. It can be used for checking planar surfaces. And one other advantage is once you set this up, if you move this 90 line to different locations, you can create a series of parallel lines. So now that you can use that for checking assemblies and gantries and slides and rails and anything you want to check to make sure it's parallel.
Is that 90 degrees here dependent on how straight this is?
Good question. Actually, there's a pentaprism in here, so the beam does not change. The 90-degree relationship between the ingoing beam and the outgoing beam remains the same.
Okay.
Even if that's moved.
Oh, interesting.
Exactly.
Okay. So you're always going to get even if this is off a little bit, you're always going to get exactly a 90-degree from the incoming beam.
Exactly. Okay. I mean, a typical example is in paper mills and applications like that. They'll set the laser up in the aisleway and they'll shoot the beam 80 or 100 feet down the aisle, and then they'll place this down at the distance to redirect the beam in to check rollers to see if those rollers are parallel.
Okay.
And that becomes important because if the material stretches over those rollers, it ultimately creates product that's not as useful as product that's lined up on straight rollers and is really flat and symmetric across.
Sure, and it's really important to get rollers, particularly on web processes. Those things got to be aligned just right on the money.
They do.
Okay.
They really do. Another accessory we have here is a cylindrical laser, and we build a variety of different lasers for customers and also a variety of different receivers to fit into small places and do things. This laser is round in nature. It, again, runs on 4 AAA batteries for about 10 hours. When we turn it on, there's a laser beam that comes out, and this beam is aligned to be parallel and centered on this mounting chuck on the back. So this can be attached into a lathe or a spindle or injection molding machines, things like that, where you want to basically check this symmetrical nature of the machine. So if you're looking at the laser and the receiver together, this will not only tell you where that alignment is up and down, left and right, basically what we call sort of the run out, but it also tells you about parallelism. You know, are these machines parallel to each other? So
I would imagine also it could tell you whether the chuck is true perpendicularly, because you would see a wobble as it turned, right? If you were to rotate it through 360 degrees and it wasn't perfectly perpendicular to the chuck, you would expect to see.
That's exactly right.
Okay.
That's exactly right. When you turn the chuck or whatever's holding this laser 180 degrees, half a turn, what you actually do is you sort of double all the errors that are in the chuck and the mounting.
Right.
So, and when you're measuring it with a receiver that can measure down to a 10,000th of an inch, you can see everything.
Okay, now I noticed on the back of this, we've been talking about one receiver, but it looks like I see on the back we've got several inputs. You can bring multiple receivers into this?
That's correct, yes. The back of this device has 4 input ports, and that basically allows you to have multiple receivers. And for example, we have a transparent receiver that can be placed into the beam path, and you can make multiple measurements along a single line.
And the beam just passes through it.
Passes cleanly through, and it takes a sample measurement at each location.
Okay. And we're starting to run out of time here, but also, I believe you said you can tie this via USB into a computer for what reason?
Exactly. Yes, there's a USB port, and we have a simple program called Pinpoint Capture that runs on laptops and PCs. It allows you to see a number of readings simultaneously if you have multiple detectors. It allows you to store those readings. It saves those readings in an Excel format, so that you can then upload them into spreadsheets or statistical programs or whatever you're doing.
Okay. So. And basic cost, kind of the base price for, let's say, what we're seeing right here, minus these options, but what do you got, the laser, the receiver, and the controller here?
Sure, yeah, this is sort of the core of the system, and there are accessories that can be added, but the typical cost begins at around $14,000. And by the time you have a lot of different accessories, you might be sort of $22,000. We also customize these as people need them to, and so we'll make fixtures or provide customers with drawings so they can make fixtures and attach them to their machines.
Okay. Well, this has been Maury Creighton from Pinpoint Laser Systems, and this was the Microgage laser...
A Microgage 2D laser alignment system.
2D laser assignment for all of your alignment needs. Well, thanks, Maury. Thanks for joining us.
Thanks for having us.
Okay, back to you, Mike.
Yep, there you have it. The Pinpoint Laser Systems Laser Microgage 2D system from Pinpoint Laser Systems. Thank you, Maury. Thank you, Dirk. Whoa, for another good Tech Corner, and keep it down there, Dirk. Come on, don't get too excited. I know that was
going to break the table.
You will, you will. But good Tech Corner there. Thank you, Dirk. Thank you, Maury, for doing that, and thank you all for joining us. Thank you, of course, to Robin Gomez of GSI Commerce for joining us via Skype. And we want to point out something. Yesterday, in case you missed it, we had
a good Gauge and Quality show.
Yes, we did. Second episode of Gauge and Quality. That was featuring basically the history of your gauge. Looking at
gauge, the value of gauge calibration history and how software can help facilitate that, make it much easier. We were looking at Gauge Pack from PQ Systems as an example of a piece of software that can help you examine your gauge history. Yep.
And that's on YouTube right now. It's going to be on our site very soon.
It's on YouTube right now.
You can check it out on our YouTube channel, Technerazi.
Technerazi Live.
Technerazi Live is our YouTube channel, so check that out and see it on our site coming up probably on Monday. So that's the show for the week. Thank you all for joining us again. Thank you, Maury, for joining us. Robin Gomez, Dirk, thank you for being here this week. It's always great when you're here. We always miss you when you're not. I know you're on vacation a lot. You have a busy jet-setting lifestyle. Thank you for being here. Thank you all for joining us. And have a great weekend, and we'll see you next week.
So long.
Thanks.